Hello everyone. Sorry about that. At the end of last one I had a bit of a mishap. And I also realized I was kind of over the amount of time I wanted to do for each one of those videos anyways. But at the end of last time I was talking about how this right here, we computed this conditional probability in somewhat of a funny way. We said, well, the probability that the second ball is red, given that the first ball was, is 8/11, because we imagine having transferred one ball over and it's red, and then we imagine taking a ball after that. And we didn't really use the formula for conditional probability that we learned on a couple of slides before this. But that's okay. We can just think our way through this one, and sometimes it's actually easier to compute the conditional probabilities without the formula than it is to actually apply the formula itself. So you just have to be flexible in that regard, and realize when it's time to actually just compute the conditional probability straight up without using that formula about intersections and things. Okay, so here's the probability that both the first and the second ball chosen are red. Okay? Part B says, what is the probability that after both balls are selected, the number of green and red balls in the first box are the same as in the beginning? And by the way, that's that's the same as the probability that nothing really changed about the boxes in terms of reds and greens, yeah? So, well, look, all that means is that either you had both red or both green chosen, okay? So let's make like another event over here on the other side of the board, okay? G1, so G1 is going to be green from the first box, okay? And G2 is going to be green from the second box, okay? And just like I did in the case of the red balls, I'm going to compute the probability that it was green first, green second. But that is the only way. It's either green first, green second, or red first, red second. That's the only way that you're going to end up with the same state as at the beginning. Because if I chose a red first, and then the number of reds goes down in the first box, and then I transfer a green over, I'm not going to have the same number of reds in the first box. I'll have one less red and one more green. And a similar thing happens if I select a green first and then a red second, okay? So let's think about this. What is the probability of G1 and G2? Well, it's the probability of G1, so we select a green from the first box, times the probability that we get a green from the second box, given that we got a green from the first box. And in a similar way to what we did for this other computation, the probability of green from the first, that is 4/10. Times, okay, the probability that we get a green from the second, given that we got a green from the first. Well, now the number of green balls has increased from 3 to 4 in the second box, and we now have 11 balls. Okay, so it's 4/11. All right? And we're being asked, what is the probability that after both balls are selected, the number of green and reds in the first box are the same? Okay, so the probability that box number one is the same, like after all is said and done. Well, one of two things happened. Either you went green 1, green 2, or you went red 1, red 2. And it's going to be the sum of those two probabilities. So it's the probability of green 1 and green 2 plus the probability of red 1 and red 2. And yeah, so we know how to compute. We already computed those two. So it's just going to be the sum of those two things, right? 4 times 4 is 16. 16 over 110 plus 48 over 110, which, by the way, is, 64 over 110. Okay, so 64 over 110 is the probability that box number 1 is the same. And by the way, that means box number 2 is going to be in the same state once this process is gone through. All right, let's move on. Okay, so here's a little picture of how to think about conditional probability. Like, I like this because it's kind of the sequential way of thinking that I've been talking about. I think about one event happening and then another event happening given that some previous event happened. So in this diagram, it doesn't use A prime like I have for like the complement. It uses A bar. So A bar means the complement of A. So it's not A, okay? So look at this diagram. So if I wanted to get the probability of A and B, which is this guy right here, well, then sequentially what has occurred is like A has happened and then B given A has happened. So the probability of A and B would be the product of those two things. It would be probability of A times the probability of B given A. What if A and not B has happened? Well, it's the same kind of idea, except you would first go here. So A happened, and then B given A, B not B given A has happened. So probability of A and B, not B is the probability of A times the probability of not B given A. Okay? And similarly for all these other things right here, you can kind of see over here we have not A and B. So like not A happens and then B happens given not A happened. So probability of not A and B would be the product of these two guys. Okay, so that's kind of what this little tree diagram is saying. Okay, fair enough. I want to look at this example though. Okay, so at a certain gas station, 40% of customers use regular gas, 35% use plus. Okay, we call that A2, the event A2. 25% use premium, that's A3. Of the customers using regular, 30% fill their tanks. Okay, so filling tanks, we're going to denote that by B. Of those customers using plus, 60% fill their tanks. Okay, of those using premium, 50% fill their tanks. Okay, all right, so let's pause right there and actually write down the information as it's been given to us. Okay, so, okay, A1 is regular, okay, A1 is regular. So let's see, I'm going to write this up here. A1 is regular. So the probability of A1 is, what do we have here? 40%, so 0.4. Okay. The probability of A2, okay, that's plus. Okay, so that's the plus, folks. Okay, so the probability of A2 is 0.35, 35%. And the probability of A3 is what? 25%. Okay, do these add up? Yeah, this is 60%, 40% is 100%. Okay. What in the world is going on with these other things? Well, this is communicating conditional probabilities to us. It says, like for instance, what is the probability that a customer will fill their tank given that they use regular? So it says of the customers using regular. So that means that we've zoomed in on the sample space onto the subset of regular purchasing customers, right? Regular gas purchasing customers. So that sentence right there is saying that the probability of filling the tank, given that it's a regular gas customer, is equal to 30%. Okay? The probability of a regular gas customer, given that they are a plus purchaser, is equal to what? Is equal to, 60, okay, 60%. Okay? And the probability that they fill their tanks, given that they are, supreme customer or premium, of those using premium, 50% fill their tanks. So the probability they fill their tanks given that they're premium is 50%. Okay? And I want to say something here that I think is kind of important. So what if I asked you for the probability that they don't fill their tanks, given that they're an A1 customer? Well, it's kind of, here's the picture, all right? So here's the whole sample space of customers, okay? And here's like the A1 customers right here. So suppose like these are the A1 customers. And like these are the A2 customers, and of course these would be A3. Then what you have here is B. B is like the collection of people that fill their tanks. Does that make sense? So if I'm computing the probability of B given A1, so first of all, A1, that's 0.4, A2 as a proportion of the entire sample space is 35%, and A3 is 25%. Okay, I just kind of drew these pictures in here. So if I want the probability of B given A1, okay, well, I know that if I do that, I'm really kind of zooming in to A1 as the new sample space for that computation. Yes? And that this right here, relative to A1, that this section right here, relative to that is the probability, right? The probability of B given A1 is equal to, it's going to be the intersection of A1 with B, okay? The probability of B and A1 divided by, right? And I have to take that relative to the relative to A1 itself. So that's why you divide by the probability of A1. You want to take the proportion that this takes up of this, where A1 is kind of like the new sample space. Okay? So that's what is equal to 0.3. So for instance, if I asked you for the probability that B didn't happen, okay, I'll use B bar because that's what I used on the previous slide. The probability of not filling up given A1, what would that be? Well, if this thing eats up 30% of A1, then what proportion does B bar eat up of A1? Well, it would be 70%. It would be basically 1 minus the probability of B given A1. So I mean, it behaves just like it did before. A1 is the new sample space. So it's 1 minus 0.3, which is 0.7. I just kind of wanted to point that out. Like, you know more than you think. If you know these conditional probabilities, you know more than you may have realized. In particular, we know the probability of not filling up given A1 also. That's important. Okay? And what about all these other this other information that's given to us? So 70% of regular fill-up customers, 50% of regular non-fill-up customers, 60% of plus fill-up, 50% of plus not fill-up. What on earth? 40% of blah, blah, blah. It's telling us the percentages of those people that actually use credit cards. So for instance, what this is saying is the probability of using a credit card given, okay, so what's going on? What's the first thing say here? 70% of regular fill-up customers. Regular is A1, fill up is B. Fill up is B, okay? So regular fill up customers. So A1 and B, the probability they use a credit card given that they're a fill up regular customer is equal to 70%. Okay? The probability that they use a credit card given what's the other one? 50% of all regular non-fill up. So A1 and B bar. What's that? 50% regular and not fill up, that's 50%. Okay? The probability of C and, all right, so what's going on here? Plus fill up. Okay, so plus is A2. Fill up is B. Okay, probability of credit card given A2 and B, what's that? 50%, 60%, okay? Probability of C and A2 and B bar, I'm assuming that's what's going to be next on our list here. Is it? Okay, so plus fill up plus not fill up is 50%. Okay? Probability of C given, let's see what's going on here. I'm assuming it's going to be premium fill up and premium not fill up. Yes, so A3 and B, and the probability of using a credit card given A3 and not B. Okay, so what's A3 and B? 50, let's see here. 50% and 40% respectively. Yeah. Okay. So look at all that information. All that information is contained in that sentence right there. All that information is contained in that one sentence. And it says compute the following events. Okay. And I don't know if we'll do all of these, but let's at least do like one of them, for instance. Okay. So for instance, what is the probability of plus and fill up and credit card? Okay, plus and fill up and credit card. Okay. Plus and fill up and credit card. Okay, so that's like the probability of plus. Plus is like A2, isn't it? Plus is A2. Okay. So it's the probability of plus, so that's A2, and fill up, which is B, and credit card, okay, which is C. Well, I can think about this sequentially. Well, they're a fill up customer, and, okay, so times the probability that they fill up given that they're a plus customer, times the probability that they use a credit card given, okay, well at this moment, they're both a fill-up customer and a plus customer. So given A2 and B. And we know all three of these things. We know what the probability of A2 is. Okay, you might be able to see that kind of right there. It's right here. It's 0.35, okay? The probability of B given A2 is 0.6, okay? So 0.35 times 0.6. What's the probability of C given A2 and B? C given A2 and B, that is 0.6, okay? And that's the answer, right? So you would just multiply those things together. Premium and credit card. That one might be a little bit trickier. I don't know. Maybe we'll just go ahead and compute all of these. This is interesting stuff here. Okay, premium and credit card. Okay, so that's the probability of. So now I want the probability of premium, which is A3, and credit card. Huh. Okay. The probability of premium and credit card. Well, It seems like that would be, it seems like that would, okay, so that would be the probability of, A3 times the probability of C given A3, okay? Or I could think about it as the probability of C times the probability of A3 given C. I can think about it in either of those two ways. But either way, we're gonna have to really think about how to get this. What in the world are we going to do to actually compute this? Because right now, I don't actually have this information right here. I have the probability of A3, but I don't have this. Okay, and so we're kind of stuck for a minute. But it turns out that we can actually pull this off. But you know what? I'm actually going to pause this thing so I don't want to get too long, and we'll come back and pick up this computation in just a minute.